San Diego Composites was founded in 2004, and we were really founded on aerospace and defense work with a focus on engineering development and manufacturing development that leads into production. I think that San Diego Composites really combines engineering and manufacturing in a way that most companies don't. I think we bring a very high level of science and engineering to our manufacturing, which does allow us to develop new processes.
STC is an industry leader in both resin transfer molding and vacuum-assisted resin transfer molding. We've been doing resin transfer molding projects with NASA since 2012. The 3D-MAT program approached us in 2013, really struggling with the ability to get the resin infused into the 3D preforms that Valley makes.
The 3D-MAT project is the first application of a woven TPS technology. Our project is intended to create a composite material that can meet the needs of the Orion compression pad for exploration missions and beyond. Compression pad is an interface between the crew module and the service module. It serves as a structural interface. It has a structural job to take all the loads of launch initially, and then it's in space. There's a power shock event to separate the crew module and service module, and then finally it serves as heat shield when the vehicle re-enters the Earth's atmosphere. As an innovative and game-changing development effort, we've had a lot of challenges along the way.
There's really two critical challenges to the 3D-MAT program. One is that the billets are thicker and denser than billets really have been stitched to date. So Valley has made some very big technology leaps there. But that created problems for the next stage, which was the infusion process. The second challenge was the fact that due to the inherent to the stitching process, each preform is a little bit differently shaped. So it makes managing the flow of the resin challenging. What we've designed is a tooling process that essentially vacates the air interstitially in the preform and then under pressure backfills that with resin. So more of like an infusion process versus a resin transfer process.
Having these processes really allows us to make state-of-the-art technology that wasn't possible even 5 or 10 years ago. And so when we're talking about, going back to the moon, going to Mars, visiting asteroids, we need these new materials and these new technologies in order to perform those missions so that they'll be successful. And so I think that's what San Diego Composites is very good at, is developing those technologies that are really expanding our abilities to go, further than we've gone before.
Partnerships have been crucial for this development effort. First of all, we don't have all the capabilities in-house at NASA. We can't do everything. So we had some great ideas, and we partnered with some excellent vendors who could help bring these ideas into fruition. So San Diego Composites is very good at overcoming composites manufacturing challenges.